You hear about the cloud all the time, right? We save our photos there, we stream movies from it, we run our entire lives on it. The name itself just sounds so light and airy and infinite. But what if I told you that's all just one of the most brilliant marketing tricks of our time? In this explainer, we're going to peel back the curtain on this metaphor to show you the massive, physical, and power-hungry machine it really is.
Okay, let's just dive right in. The very first thing we have to do is completely change how we think about what the cloud even is. It's not a weather pattern, folks. It's heavy industry.
I mean, it's a super simple question, but one we almost never stop to ask. When you upload a photo, where does it go? It just seems to, poof, vanish into the air, ready to be pulled down anywhere, anytime. But it doesn't just disappear.
This quote right here just hits the nail on the head. The cloud isn't some abstract idea floating up in the sky. It's real, it's tangible, it's buildings, racks of powerful computers, and a huge web of actual physical cables.
So here you go. Take a look. This is the cloud. A massive campus of enormous windowless buildings, just packed to the gills with computers. And this is just one of thousands of these places that make up the real foundation of our digital world.
So what's actually happening inside these giant buildings? Let's take a look. Think of them less as offices and more as the factories and libraries of the digital age. Officially, yeah, it's a data center, a place to house computer systems. But really, every single thing you do online, every website you visit, every email you send, every single cat video you watch, it all lives on a physical server inside one of these buildings. And when you peek inside, it looks way more like a power plant than a tech company. It's not just the servers, it's all the stuff you need to keep them running. We're talking huge cooling systems, giant backup diesel generators. The whole shebang is designed for one thing, to make sure the power never, ever goes out.
And the scale of this is just, it's staggering. Get this number, 5,381. That's how many data centers there were in the United States alone as of March 2024. That is the most of any country in the world, and that number is just constantly climbing. Okay, so if the data centers are the brains, how in the world do they all talk to each other across oceans and continents? The answer probably isn't what you think. It's got nothing to do with satellites or some giant Wi-Fi signal in the sky.
This is one of the most surprising facts about the internet. You know, we live in this wireless world with our phones and laptops, but almost all of the data connecting our continents is actually traveling through physical wires.
The internet's real nervous system is this huge network of submarine fiber optic cables. Hundreds of these things, some of them stretching for thousands of miles, are just laid out on the ocean floor. They are the physical wires that let you pull up a website from another country in less than a second. And the sheer capacity of these cables, it's just hard to wrap your head around. A single cable, maybe about as thick as a garden hose, can transmit data millions of times faster than your Wi-Fi at home. It's an absolutely incredible piece of engineering just snaking along the bottom of the ocean. So, now that we kind of get the immense physical scale of all this, let's talk about the staggering costs of running this global factory. Especially now, with the explosion of artificial intelligence pushing this whole system to its absolute limits. And you can see it in the spending. I mean, look at this chart. Capital expenditures from the biggest tech companies are just going through the roof. They're projected to hit around $200 billion in 2024. And that massive jump, it's almost entirely driven by the race to build out infrastructure for AI. So here's the crucial point. All this hardware needs an unbelievable amount of electricity. As far back as 2022, data centers were already gobbling up to 1.3% of all global electricity. And that was before the current AI boom really took off. Some estimates say that demand is going to double by 2026. And you won't believe where that energy actually goes. Only about 12% of it is used to power the actual servers doing the work. A massive 40% is dedicated just to cooling systems to stop them from overheating. It literally takes more energy to cool the cloud than it does to run it. And this has very real consequences for the people who live nearby. This quote just captures it perfectly. It's the experience of a constant, high-pitched hum from those massive cooling fans, creating noise pollution that can seriously impact people's lives. Beyond electricity, there's water. These places rely on cooling systems that use astonishing amounts of water. We're talking millions of gallons a day for a single facility. And often, they're built in regions that are already facing water shortages. So with the demand for computing power just absolutely exploding, the whole industry is in a frantic race to reinvent its own foundations. So let's take a look at what's coming next. To handle this demand, the technology itself has to change, and radically. On the left, you've got a traditional air-cooled server room. But on the right, well, that's the future for AI. It's called immersion cooling. They're literally dunking the servers in liquid because they generate way too much heat for plain old air to handle anymore.
But even with better cooling, the real problem is just generating enough power. And the industry is now making very serious moves toward nuclear. This timeline shows the path for what a lot of people see as the ultimate solution, small modular reactors, or SMRs. But as you can see, this isn't an overnight fix. The first commercial ones aren't expected until 2030 or later.
And this is what that future might actually look like. It's a rendering of a small, self-contained nuclear reactor designed to provide clean, dedicated power to a data center campus. Yeah, it's a radical solution, but it's being pursued to meet a pretty radical level of demand.
So we've gone from the myth of this weightless, ethereal cloud to the reality of a planet-spanning physical machine that consumes huge amounts of land, power, and water. And that brings us to the final, crucial point, and the big question we're left with. As our hunger for data and AI grows exponentially, can our physical world with its very real, very finite resources actually keep up?